slowly when forming, allows larger crystals to form. Complex pegmatites like the Rutherford No. 1 and 2 mines have extraordinary elements present that allow rare and unusual minerals to form. Next slide. This shows the location, hard to see the arrow there, but it shows the location of the Rutherford mine, which were about 45 miles southwest of Richmond. Next slide. At this point, Thomas, if you could briefly jump to page 5, I would appreciate it, to slide 5. So that's 3, jump to 4, then to 5. Now go to 5. Next slide. Back to slide number 5. That's slide number 6. Back 1.
There's a little bit of a lag.
That's no problem there. During the last few weeks, I had access to the historical archives of the Rutherford mine, and much of the final research I've done with the mine, including some major corrections, were done based on this research. You can see from the slide, until its closure in 1998, the Rutherford mine was one of the most important sources in the United States for the collection of rare earth and niobium and tantalum bearing minerals. And you'll notice the initial paper on the pegmatite was published in 1883 by Fontaine. Subsequently, well, we're noting papers in 1928, 1935, 1968, and 1998. This is the first major study done since 1998, but all of these papers will be referred to during the course of the presentation. Thomas, if you could go back to slide number 3, I would appreciate it. In 1935, Glass reported that the earliest workings of the mica deposits near Amelia Courthouse were thought to have been done by Native Americans for use in ornamental jewelry, with early settlers reporting the removal of mica from the upper 10 feet of the vein. The earliest recorded mining was for muscovite in the No. 1 pegmatite beginning in 1873. Eventually, both the No. 1 and No. 2 pegmatites were mined through the 1870s and 1880s for the mica that was used for industrial purposes, with about 200,000 pounds extracted during this period. Sporadic operations continued until 1912, when the pit in the No. 2 pegmatite began to fill with water. Collecting in the pegmatites began in 1881, 2 years before William Fontaine wrote the first paper on the Rutherford mine. From 1912 to 1932, 15 tons of gem amazonite were taken from the No. 1 pegmatite by the American Gem and Pearl Company for the German markets, which preferred the lesser grade variety because the highest and pure greenish blue translucent variety was too cleavable. In 1968, Sinkankas described this highest grade as the finest found anywhere in the world. From 1958 through late 1959, the Piedmont Mining Company, operated by Warren D. Bill Balsley, leased the Rutherford mine from property owner Crawford Keener, briefly mining the No. 1 pegmatite for amazonite and the No. 2 pegmatite for mineral specimens. The mine was open to the general public, as you can see here, from the 50s through the 80s. And after the death of property owner Crawford Keener, it was kept open over the annual Labor Day weekend for a small gem and mineral show until the mine was permanently closed after the Labor Day weekend in 1998. I'd like to note here that the variety and perfection of many of the original species found in the #1 and #2 pegmatites, including microlite, 6 to 8 pound crystals of columbite and monazite, and Beryl crystals exceeding 4 feet in length, led to their inclusion in many of the world's museums. Unfortunately, most of the specimens collected in the #2 pegmatite for US museums ended up in the Academy of Natural Sciences in Philadelphia, which, because of cash difficulties, sold off their entire collection to a private dealer in 2006. Next slide. This photograph of an early trip by the Richmond Gem and Mineral Society was actually taken in the early 1960s. Next slide. We've already looked at this slide. Let's take a look at the next slide. Our study is the first to use modern analytical techniques such as energy dispersive spectroscopy, EDS, in the study of the minerals of the Rutherford #2 pegmatite, and is the first after the 2010 update and reorganization of mineral species, of mineral groups, I should say, by the IMA, International Mineralogical Association. It is also one of the first to take a closer look at the minerals of the Pyrochlore supergroup since the reorganization. Although this reorganization was controversial, it is the minerals of this newly organized supergroup which will be featured in the presentation. Next slide. This shows the abundant rock-forming minerals that occurred in the pegmatite. Should note here that the moonstone found at the Rutherford Mine should more accurately be described as oligoclase variety peristirite, as moonstone is a lapidary term. Also, the gem variety of smoky quartz known as cairngorm was only found in the early days of the mine, and toward the end you'll notice most collectors have specimens in their collection labeled sericite. Sericite, the term has been discredited. It is now more accurately described as a fine-grained variety of muscovite. Next slide. Fluorite variety chlorophane was both fluorescent and thermoluminescent and will be discussed later in the presentation. Almandine was described in the early days of the pegmatite, but was later determined to be spessartine with a higher degree of iron in the samples. The tourmaline supergroup included members of the schorl gravite series, and like spessartine will be discussed later in the presentation. The information I just shared with you is not necessarily what you're seeing on the page. Like I said, the recent research I've done in the archives have, let's just say, fine-tuned the presentation a bit. But I will say that all of the, under many of the very microcrystals were only visible under high magnification. Next slide. This is another change. All of these metallic minerals were rare in the pegmatite, but upon further study, I have determined that none of these sulfide minerals were deposited in the late stages of mineralization. Next slide. As mentioned earlier, the Rutherford Mine was considered one of the most important collecting sites in the country for rare earth minerals. This slide shows some of the important metals derived from these minerals. You can see most of these are minerals in the considered to be rare earth minerals. Next slide. The Pyrochlore supergroup consists of the tantalum-dominant microlite group and the niobium-dominant pyrochlore group. During the time that field collecting took place in the mine, microlite had not yet been organized into a separate group of mineral species, and Rutherford collectors still refer to the mineral by this name. The reorganization referred to earlier, though highly unpopular with collectors, was made because of improvements in analytical research. These changes will be discussed later in the presentation, as they are the source of my decision to begin research into those members of the newly organized supergroup that occurred in the pegmatite. Next slide. Based on my research, only about 0.5% of the clevelandite collected at the Rutherford Mine demonstrated fluorescence. What I'd like, Thomas, what I'd like you to do is toggle briefly back and forth slide number 2 and slide number in the next 13. You'll notice here, it's showing a kind of unusual lattice fluorescence with shortwave that's much brighter with the long wave fluorescence. My friend Michael Pabst and I studied this at length, and you'll notice here, hard to tell, but you'll notice that some of the fluorescence kind of gets a little bit brighter in the middle of the streak. Go to the next page. You'll see little brief nodes here. Based on our research, this may be due to inclusions of fluorescent fluorapatite nodules, which have rarely been observed on the surface fractures of albite variety clevelandite. In fact, Rudy, sometime years back, was one of the first to look at this besides me, and he said it was the craziest thing he'd ever seen from Rutherford. Next slide. The question of whether this deep blue-green variety of microcline variety amazonite may actually have been blue albite has been resolved, although close examination of such samples sometimes showed a glacial ice blue color. Research into the early days of the mine showed that this indeed was amazonite. Notice in this beautiful specimen the very sugary-looking coating of the white crystal. This is not bavenite. This is very sugary, fine-grained muscovite, formerly referred to as sericite. And also notice on the amazonite, the weird gridiron structure. That's a very, very unusual sample. Next slide. There were so many unusual things in the Rutherford pegmatite, and this is one of them. These kind of stacked little wafer-like crystals of calcite, very unusual. In fact, Tony Nickisher of Excalibur Mineral commented that this was one of the more unusual examples of calcite he has seen, and he's seen lots of varieties of calcite. Next slide. Bavenite is a relatively rare beryllium silicate that was common in the pegmatite, usually occurring as matted crystals on the surfaces of quartz or as tufts of terminated crystals in the interstices of clevelandite. The uncommon variety of quartz in which the bavenite occurs in this photograph was ubiquitous at the Rutherford Mine. Tommy, you might find this interesting. Quartz with filiform tourmaline crystal inclusions was first studied by Gerald McCarthy of the American Mineralogist in 1928. The needle-like crystal inclusions were first thought to be those of rutile, but after testing for titanium with negative results, the crystals were thought to be examples of bisylite, a common variety of actinolite. However, in 1964, Dr. Mitchell of the University of Virginia reported that after microscopic study, these loosely matted crystals that caused the discoloring in quartz consisted of filaments of tourmaline in the Schorl Gravite series measuring 0.005 of a millimeter in diameter. Might also note here that near microscopic crystals of tourmaline were frequently found embedded with minute muscovite crystals on the surfaces of clevelandite blades. Next slide. This is a beautiful picture of some muscovite crystals jutting out from some clevelandite. Clevelandite has been discussed earlier in the presentation, and until recent discoveries in the pegmatites of Pakistan and Afghanistan, the Rutherford #2 pegmatite was considered to be the best source in the world for high quality specimens. Next slide. I might add here, no one has asked a question, probably will come at the end, as far as the field of view of these specimens. Many of these, some were larger, but many of these were much smaller and were taken under high magnification. I regret that I don't have specific field of views for each photograph. This slide, there were 5 varieties of fine-grained muscovite in the Rutherford Mine pegmatites, and the pinkish lilac variety was the rarest. Next slide. This shows some blue hexagonal fluorapatite crystals with cassiterite and clevelandite. Non-fluorescent crystals of fluorapatite such as these were rare in the pegmatite and were reported by Sinkankis in 1968 to possibly be due to tourmaline inclusions. Next slide. This is the only example I have in all of my study, and I'm thinking that transparent pink crystals of fluorapatite were very rare. Next slide. Terminated microtourmaline crystals were often found in the interstices of clevelandite in the early days. They bear some resemblance to stibnite crystals, but this is unlikely because stibnite was reported rarely only in the very early days of the mine. Next slide. Microcrystals of orthoclase variety Adularia have also been observed forming on the blades of clevelandite crystals embedded with micromuscovite crystals. These were likely formed during a late stage of mineralization. This is one of my favorite photographs from Michael Pabst. Next slide. Incidentally, was very fortunate. Michael Pabst, who does the Mineral Mite newsletter for the micromineralogists of the micromineralogists of the National Capital Area, has won a national award for his newsletter and is considered to be one of the best photomicrographers in the United States. I first met him in the Shenandoah Club, of which Tommy is still a member. In this photograph by Michael, this is a rare example where the filiform tourmaline crystals can be clearly observed as inclusions in quartz. Hello. Next slide. Very large crystals of yellow beryl were found, especially in the #1 pegmatite. However, the gem variety was found in the #2 pegmatite, golden beryl variety Heliodor, but it was very rare. Next slide. This fairly large and beautiful crystal of helvine is another example of a rare beryllium silicate found in the pegmatite and was usually found in association with spessartine. Next slide. This is a very unusual example from the Rutherford Mine because bicolored fluorite was seldom reported, and yellow fluorite was rarely seen. Here it's in association with cassiterite. Next slide. In this photo taken by Richmond Club member Rudy Bland, these zircon crystals were associated with the rare earth minerals found in another part of the specimen. This was their general presentation in the pegmatite, and in 1928, Pegau reported that many of these curved crystals were examples of spessartine, a hydrous uranium and thorium bearing variety. Next slide. Screening was prohibited by property owner Crawford Keener in the 1960s and 70s, but it was the only way in which beautiful floater crystals like this could be found. Next slide. This is mentioned electron energy dispersive spectroscopy 4. This is our introduction. To begin the process of identifying the minerals that occurred in the Rutherford #2 pegmatite, I began working with Tony Nikisher of Excalibur Mineral in 2016 to tentatively identify selected samples using energy dispersive X-ray spectroscopy, or EDS, which is the chemical microanalysis technique used in conjunction with scanning electron microscopy, SEM. In 2017, Dr. Mike Wise of the Smithsonian Institution joined the research into the minerals of the Pyrochlore supergroup found in the Rutherford pegmatite, and the results of this research will be discussed near the end of the presentation. Next slide. Jarosite is a rather common mineral, but was very rare at the Rutherford mine and not identified until 1968 by Dr. Mitchell of the University of Virginia. You'll notice here the EDS test results and the identification of this as the jarosite pseudomorph after a distorted arsenopyrite crystal. In this case, the EDS test results reveal a possible reporting error made by Johnson Kankis in his paper of the same year when he reported the presence of lurlingite, an iron arsenide with a very similar chemical composition to arsenopyrite. The EDS test results indicate what may have happened, as pseudomorphs are notoriously difficult to analyze. It seemed likely that distorted and discolored crystals like these is what caused Mr. Kankis' confusion, and is a good example of how modern analytical techniques can enhance mineralogical clarity. Next slide. Xenotime Y, first reported by Lumpkin in 1998, was one of the rarest minerals in the #2 pegmatite, and this is one of the best examples found. Here, it's shown in association with Manganese-dominant. Note the chemical composition of the mineral, which is yttrium phosphate, and compare it with the EDS test results, which shows a little bit of aluminum, yttrium, phosphorus, some thorium, neodymium, iron, and tantalum. This illustrates why the more abundant of the rare earth minerals, most notably monazite Ce, are such important sources of all the elements in this group, which are used extensively in high-tech industries. Next slide. Fergusonite, or yttrium niobate, is an uncommon rare earth mineral that usually occurred in the pegmatite as vitreous black masses in association with allanite Ce. Tapered crystals such as these were rare. Next slide. This is the first example in the presentation of Fluoricalcio-microlite, a tentatively confirmed, newly identified member of the microlite group. In this very fine photograph, you've got a monazite Ce crystal on the left and the Fluoricalcio-microlite on the right. Research on the members of this group will be discussed later in the presentation. Next slide. This is where he had to make a few corrections. In 1967, Duncan Riesmeyer of the University of Virginia first described basnasite Ce as a component of the commonly formed brown alteration lines around the black allanite Ce crystal. And in this example, the alteration is almost complete because only in the upper central part of the photograph will you still see some of the allanite. In addition, about 10 years ago, Lance Kearns of James Madison University identified the small pinkish area kind of to the lower right of the allanite of this sample to be rhabdophane Ce, a very rare earth mineral which is not listed in Mendat and had not been previously reported as occurring in the pegmatite. Now, to correctly identify the colors, the allanite should be identified as kind of the blackish, the basnasite as brown, kind of tannish brown, and the rhabdophane as reddish. These corrections will be noted in my presentation next year. Sorry about that. Next slide. This very small sample clearly illustrates the alteration process involving allanite CE becoming basnasite CE. And if you look to the lower left, there's a tiny little piece that I'm thinking might be rhabdophane, but there's certainly not very much there. Next slide. This is another small specimen provided to me by Richmond Club member Betsy Martin, and it's a mixture of about 90% brochite and 10% thorite. The brochite being a calcium, thorium, a hydrous calcium, thorium, cerium phosphate, and thorite being thorium silicate. EDS results shown on the bottom. Brochite represents a second species in this presentation, not listed in MNDAT, and is the first reported occurrence of the mineral in the pegmatite. Thorite had been first reported by Lumpkin in 1998. Next slide. One of the purposes of the Rutherford Mine research was to establish a greater degree of clarity with regard to the Columbite-Tantalite series of minerals. The analysis of this sample shows that indeed, niobium and tantalum were both present, with niobium being the dominant element. In the early days of collecting at the Rutherford Mine, this mineral was identified as tantalite. In later years, specimens were identified as examples of Columbite-Tantalite, a term still used in the excavation of this strategic mineral. However, the correct species name for the samples found in the Rutherford pegmatite is Columbite-Fe, with the EDS test results properly reflecting the greater presence of niobium as compared to tantalum, as well as a significant amount of constituent iron. Next slide. The much less common Mangano-Tantalite, or Tantalite Mn, was distinguished from Columbite-Fe by its hints of red flashes and to a lesser degree its conchoidal fracture. Next slide. On this one, I will readily admit to cheating a little bit, and because you can't really tell because of the logo here on the lower right, but in this specimen, the amount of there was a slightly larger presence of manganese over iron in the sample, which identifies it just barely, those are Tony Nickisher's words, as an example of mangano-columbite, or Columbite Mn, which would be the third species discussed so far that is not listed in MNDAT. This is interesting though. The analysis suggests that both Tantalite Mn and Columbite Mn were present in the pegmatite, and that due to the abundance of Columbite Fe, many of the specimens previously identified as being examples of Mangano-Tantalite were actually examples of this similar species. I would go out on a limb and I would say that probably 2/3 to 3/4 of specimens that right now we call Mangano-Tantalite were actually Mangano-Columbite. We won't know until we test every blasted one. Next slide. Fluorite variety chloraphane was originally associated in the matrix with microlite and other rare earth minerals, and is one of the most remarkable varieties of fluorite known. Both the colorless and green varieties exhibited an unusually strong fluorescence an enduring blue-green phosphorescence when exposed to ultraviolet light, which persisted after being removed from the source of heat. Next slide. Fluorite crystals were rare in the pegmatite and were usually white, pale green, or wine red in color. Only the white and pale green varieties, usually found in the interstices of clevelandite, exhibited yellow fluorescence. Next slide. Adamantine partial crystals of spessartine were uncommon on the dumps of the pegmatite through the 1990s and rivaled in quality those found in the pegmatites of Ramona, California, as the finest found in the United States. Spessartine was first described in the mineralogical notes of the U.S. Geologic Survey in 1890. Early in the Rutherford Mine's history, as I reported, the deep red-orange variety was thought to be almandine, and later it was found to, as I mentioned, about the constituent iron. And in a discussion with Pete shared with me that the lighter manganese-dominant orange colors developed in the later stage of the mineralization. The famous Rutherford Lady, a 2,800 carat crystalline mass, was found by Richard Seaver over the Labor Day weekend in 1991. But in 1973, a 5.9 pound gem was also found, and occasional finds of well over 100 carats were not uncommon. I'd like to share here that the parallel striations in lozenge-shaped pits found in many crystal masses were due to their initially being found in matrix with the platy and reticulated large masses of clevelandite. Next slide. This picture illustrates the change in color as the manganese, as the more manganese-dominant spessartine, well, I should say as the more iron-dominant spessartine transition gradually to the more orange-colored manganese-dominant spessartine. Next page. Next slide, I should say. Next slide. There we go. This is what I've been referred to a couple times earlier, and I've made many people mad about this, including my dear friend Pete McCrary. An introduction to the Pyrochlore supergroup. The article titled "The Pyrochlore Supergroup of Minerals Nomenclature" appeared in the Canadian Mineralogist in 2010, and it discussed a change in nomenclature which had recently been approved by the International Mineralogical Association. At the time, the decision was made that the pyrochlore group should be reorganized as a pyrochlore supergroup, with both the microlite group and the pyrochlore group being members of the new supergroup. In the process, microlite and pyrochlore were discredited as individual species. Sorry about that, guys. With a 2014 edition of Fleischer's Glossary of Mineral Species, probably the most unpopular book written in the 21st century, reflected those changes. Next slide. This is continued in an introduction to the pyrochlore supergroup. Earlier, we discussed how energy dispersive X-ray spectroscopy was used to test selected samples from the pegmatite. As Tony Nickisher of Excalibur Mineral began testing samples of the microlite group, the results suggested that Fluorocalcio-microlite was the dominant species that occurred in the Rutherford pegmatite. 5 typical olive green to brown microlite group crystals were tested, showing the following range of chemical composition. Now, I'd like to share this, some additional information about microlite. In 1935, Jewel J. Glass reported that the olive brown variety of microlite was usually embedded in chatoyant albite variety pyristyrite, otherwise known as moonstone, while the amber and reddish yellow varieties, many of which were transparent, occurred in the interstices of clevelandite. Glass was also the first to report that X-ray analysis of both varieties had shown a high degree of absorption, indicating that because of the disruption of the crystal structure by radiation from contained or nearby radioactive atoms, the crystal structure had become amorphous or metameric. Unlike Dr. Mitchell's studies in 1970, my own research showed a clear distinction between the tantalum-rich member of the microlite group, illustrated here, and a single example of a niobium-rich member of the pyrochlore group, which will be shown later in the presentation. Consequently, it is my view, and we'll discuss a bit later, that members of both these groups were present in the pegmatite, and this we'll talk about it later. Again, what we're looking at here is we're definitely showing in these samples tested a clear preponderance of tantalum over niobium. Further, in 1998, Gregory Lumpton conducted the most thorough analysis of the microlites of the #2 pegmatite to date. Using both infrared spectroscopy and thermal gravimetric analysis of selected samples, the analyses showed total H2O constituents ranging from 0.5% to 3.5% by weight, with little indication of the OH molecule. The EDS testing results reported in this presentation, as well as Dr. Wise's studies, which were reported at the end of this presentation, strongly indicate that Fluorocalcio-microlite was the dominant species in the group. However, lacking test results from X-ray or Raman spectroscopy, as well as electron probes, Lumpkin's analyses suggest that in addition to what's been reported in this presentation and what will be reported shortly, a water-bearing member of the microlite group may also have occurred in the pegmatite. Next slide. This is an example of the microlite group. I would like to add here that this is where a few more changes need to be made, because as of this writing, a 12th member has been added, and also I would like to change, just to be in the safe side, I'm going to say tentatively confirmed on the Fluorocalcio-microlite and tentatively identified on the 2 species shown toward the bottom. You'll notice Keno-plumbo-microlite, IMA identified in 2010, and this is brand new. Oxycalcio-microlite has now, just this year, been recognized by the IMA. We now have 2 pegmatites from Brazil reporting oxycalcio-microlite, 2 in northern Italy, 1 in Sweden, and I'm reasonably confident that we can say we have an additional locality at the Rutherford Mine #2 pegmatite. Next slide. I might add here one more thing here in talking about the unpopular changes and were made. The changes that were made in 2010. I pursued the research because my longtime interest in the Rutherford Mine kind of spoke to me and said it was time to take these changes seriously and to further conduct research into just which members of these groups actually occurred there. This slide here, this photograph, is the first example of a typical, what we all lovingly refer to as a microlite. I'm now calling it tentatively confirmed pretty confidently as being an example of Fluorocalcio-microlite. Show the EDS test results at the bottom. Next slide. This is hard to tell here. This is not black. This is a much darker brown, more of a brownish black variety of a microlite crystal, Fluorocalcio-microlite crystal. Next slide. Before I continue on here, I might add that the 6 to 8 inch wide crystals that were reported from the #1 pegmatite in the late 19th century are still by far the largest ever found in the world. And in 1918, Samuel Gordon reported that microlite crystals up to 3/4 an inch in diameter from the #2 pegmatite were available, quote unquote, by the pound back in 1918. Now, in this photograph, this shows some slight degree of radioactivity. Turns out all samples of microlite group species are slightly radioactive, even though neither uranium or thorium showed up in any of the EDS test results. As reported earlier by Glass, this is because they're generally zoned in metamix. This sample was interesting because of the lack of detectable niobium, as you can see at the bottom there. Later in the presentation, I will show why most of the slight radioactivity was probably due to the presence of thorium rather than uranium. Next slide. This is one of my very favorite microlites that I got when through Pete McCrary's wonderful generosity. This is a very unusual orange microlite. Test results at the bottom, and I'm thinking that the trace aluminum along with the iron may be responsible for this unusual orange color of this very rare sample. Next slide. This amber red variety of fluorocalcio-microlite was also extremely rare. Interestingly, this sample registered the highest fluorine percentage by far of any sample tested. Next slide. Yellow varieties were also very rare, and several samples not pictured here were tested for possible evidence of another microlite group species that may have occurred in the pegmatite, fluornatromicrolite. The results were inconclusive. Next slide. Gemmy examples of fluorocalcio-microlite were very rare, and crystals were usually too small to facet. In 1882, microlite was considered the rarest gem in North America, and it was at that time that a hyacinth red 3.66 faceted stone was put on display in the Hall of Gems in the Smithsonian Museum of Natural History. In 1975, I found a crystal fragment of similar color that was faceted into a 2/3 of a carat stone for my first wife's engagement ring. As far as I know, she's the only person to ever wear a gem microlite in a ring. Guess I won't see that one anymore. Next slide. This is a beautiful example of a very gemmy fluorocalcio-microlite in Clevelandite. Next slide. As noted, fluorocalcio-microlite has been tentatively confirmed as the dominant microlite group species occurring in the pegmatite. What follows are photographs of the species that have been tentatively identified. Next slide. This lead-bearing member of the microlite group was extremely rare in the pegmatite and only found at very small crystals. It is otherwise currently known only from a single pegmatite on the Kola Peninsula of Russia. At a recent meeting of the Richmond Gem and Mineral Society, I was getting excited saying, gosh, this is one of the rarest minerals in the world. But someone corrected me in saying, it might be one of the rarest minerals in the world, but if it's tiny and ugly, you've got to find a buyer first. He was quite honest in that assessment. But in this case, two interesting things here. First off, notice the extremely unusual formula of the Kino-Plumbo microlite. Many of you have probably not seen Kino in a mineral formula name ever before. Kino refers to those weird squares you see in the very accurate chemical composition, which comes right out of Mendet. Those reflect vacancies in the crystal structure of the mineral. And if you notice at the bottom, the EDS test results clearly show a high presence of lead in the specimens. Go to the next slide. This next one is an extremely rare crystal of the same mineral. And you don't want to ask me whether I accidentally lost this crystal. You just don't want to ask me that. So let's just move on to the next slide. It happens when you're looking through thousands of rocks. Go back to the previous slide. Previous slide. Previous slide. Next slide. Unless we lost it. Oh, I'm sorry. Oh, should have had more sleep last night. This one shows another photograph of the Kino Plumbo microlite, little crystals in the black, on the right side of a brownish Fluorocalcio-microlite. Apologize for that, folks. Next slide. Okay, now we're caught up. This is the third microlite group species tentatively identified by EDS testing. Note the unusual greenish yellow color of this perfect crystal and its simple chemical composition, niobium, calcium, and tantalum. This was identified by Tony Nikisher of Excalibur Mineral. He and I both are very confident that this is Oxycalcio-microlite, and at the time this was analyzed, it still had not yet been officially recognized by the IMA. Obviously, this is one of my favorite photographs of the whole specimen, and probably the rarest mineral in my entire collection and it's also even a little bit pretty. Next slide. And Thomas, if you would, toggle back between this slide and the following slide. And go back to the other slide. This slide, by the way, this would be a good place to, I believe my friend Ron Tucker is watching the presentation this evening. I would like to give full acknowledgement to him because great percentage of the material I've used in my research came from him, and particularly this specimen. This is an extremely unusual example of two possibly different microlite group species occurring in discolored and fluorescent Clevelandite, which, as I mentioned earlier, was very, very rare in the Pegmatite. So here you've got the gemmy Fluorocalcio-microlite, and here you've got the lime green, likely Oxycalcio-microlite. Next slide. And then we go to the slide after that. In 1959, Allison Cusick, this is completely revised here. Allison Cusick noted that pyrochlore was rare in the #2 pegmatite. Hatchetolite, which was first identified as the Uranian pyrochlore and later simply as pyrochlore, was discredited as a mineral species long after Dr. Mitchell of the University of Virginia in 1970 disputed Samuel Gordon's identification of the mineral in 1918. However, black octahedral crystals were found rarely through the early 1970s, and these may have been examples of another uranium-bearing member of the pyrochlore group, although testing results are missing from the archives. One possible reason for the rarity of uranium minerals is that, as reported by Dr. Mitchell himself in 1967, thorium appeared to be the dominant radioactive mineral found in the Rutherford number 2 pegmatite due to its presence in many of the rare earth minerals found. The thorium mineral reported later, thorite by Lumpkin in 1998, and brockite in this presentation would suggest that, based on my research and a chemical formula very similar to the composition of the minerals in the pegmatite, my best guess is that if there was a uranium pyrochlore present in the pegmatite, it may have been fluorplumbopyrochlore, chemical formula lead, yttrium, thorium, uranium, sodium, calcium, in a niobium titanium oxide with fluorine. Interestingly, this species is very similar to plumbopyrochlore, which was first reported by Gregory Lumpkin in 1998. Next slide. And go to the next slide. As mentioned earlier, this is the single sample in the presentation that is identified as being a niobium-dominant member of the pyrochlore group. This suggests that though rare, other pyrochlore group species may have been present in the pegmatite. Incidentally, if you could go back to the previous page, just for a second. Like I said, these two pages are being revised. The correct title of both this page and the previous one should be titled Further Research into the Minerals of the Pyrochlore Supergroup, the Hatchetite Problem, in which we just discussed. I'd like to add here that during my research with the Rutherford Mine collection, the Laura Robbins Gallery from Nature, I learned that the great majority of specimens labeled hatchetite were clearly examples of Fluorocalcio-microlite, the dominant microlite group member in the pegmatite. Several specimens with small black crystals fit the profile for what I've tentatively identified as being examples of microlite. And interestingly, there was a heavy sample with small black speck throughout that matched up perfectly with Lumpkin's 1998 identification of plumbopyrochlore. Obviously, these things await further testing if it ever happens. Next slide. And we can go to the next slide. These show my research findings. Many rare species. The ones they listed here, allanite, CE, bavenite, fergusonite Y, and tantalite MN are some of the ones that if somehow somebody managed to get into Rutherford Mine today, things you quite possibly could find. We discussed the newly identified members of the pyrochlore supergroup, the presence of many exotic elements, and earlier we showed the rare odd pattern of the fluorescence in the albite variety Clevelandite, possibly caused by lattice inclusion of the fluorapatite nodules. Next slide. Finally, we get to the conclusions drawn from the research with Dr. Mike Wyther, the Smithsonian. X-ray diffraction results were inconclusive because all samples tested were metamixed. This was true regardless of the sample's color or how glassy they were. In addition to the radioactive elements reported by Lumpkin, the 1 to 2% yttrium detected in the samples might have destabilized the crystal structure. Not only had the presence of yttrium in microlite group species not been previously reported, but this is the first study I know of to report a non-radioactive element having an effect on the crystal structure of members of the microlite group. Finally, numerous tests done both by XRD and EDS analysis of the elements present do suggest that Fluorocalcio-microlite was a dominant member of the microlite group, and this is the first time Fluorocalcio-microlite has been reported in North America. Next slide. Okay, now we get to another controversial part of the presentation. Suggestions for collectors. I do this with a bit of tongue-in-cheek. Most collections containing Rutherford minerals have specimens labeled microlite. Since microlite is now the name of a mineral group and the species name superseded, we suggest that the olive brown to brownish black examples of microlite, as well as the rare bright yellow and amber red varieties, be relabeled Fluoricalcio-microlite, or if preferred, microlite group. Our research to date suggests that 98% of the microlite is Fluoricalcio-microlite. I might add on here that I was speaking to a collector recently, and he said, well, what you've got is microlite, and these are just varieties of microlite. These are not varieties of microlite. If you took a look through the slide, each individual species of microlite in the microlite group has a distinct and separate chemical composition, which distinguishes them as individual minerals in the new organized microlite group. Now, like I said, everyone has their own opinion. I'm going to stick to mine. Regarding other varieties featured in this presentation, including the yellow-green to lime-green crystals of Oxycalcio-microlite and black crystals of Keno-plumbo-microlite, use of these names should be restricted to specimens that have been analyzed, although the habit of the lead-bearing species Keno-plumbo-microlite, especially when associated with other members of the microlite group, makes the identification of this extremely rare species very reliable. Next slide. Ongoing studies. Yes, and I'll be saying something about this in a moment. Just because this is the final version of the presentation, did I mean if somebody brought me a box of Rutherford minerals and saying, what you got there, does that mean they wouldn't look at it? No way. So that's why I guess I can say that further study of the minerals will probably occur, and I'll may even do some more EDS testing to try to nail down something like a fursmite that Lumpkin reported, or a plumbo pyrochlore, or whatever. The research I'll refer to with the Laura Robbins Gallery has been completed. And this research has made possible the finalizing of an arrangement where my entire Rutherford Mine collection will be donated to the gallery later next year. This will further a goal of the Virginia Mineral Project to have the best available specimens from this historic locality permanently on display in one place, with many others available for future generations to study. Following the example of my friend Pete McCrary, I am encouraging other Rutherford collectors to join me in this effort. Additionally, as I've said here, once we've come out the other side of our current situation, I would be happy to look through any other unclassified collections or boxes or buckets or bags of Rutherford Mine material that may still be out there. So now let's move to the final page. These are my acknowledgments to my friend Michael Papp for his friendship and his hard work making this presentation possible, for Pete McCrary for his encouragement and a wonderful generosity and the knowledge shared with me over the years, to Tony Nickisher of Excalibur Mineral Corporation for his advice and analysis of the rare minerals of the Rutherford Mine, to Betsy Martin and Rudy Bland for their invaluable service to the mineralogical community, to Mike Wise for his support with ongoing research into the Pyrochlore supergroup, and to Frank Creighton for introducing me to the joy of collecting at the Rutherford Mine and digging in the dirt for so many years. And that is the conclusion of my presentation.